PTS-DOS, short for Disk Operating System, is an acronym for several closely related operating systems that dominated the IBM PC-compatible market between 1981 and 1995, or until about 2000, including the partially DOS-based Microsoft Windows versions 95, 98, and Millennium Edition. Related systems include MS-DOS, PC-DOS, Dr.DOS, FreeDOS, ROM-DOS, and PTS-DOS. In spite of the common usage, none of these systems was simply named DOS. A number of unrelated, non-x86 microcomputer disk operating systems had DOS in their name, and are often referred to simply as DOS, when discussing machines that use them. While providing many of the same operating system functions for their respective computer systems, programs running under any one of these operating systems would not run under others. History. Origins: IBM PC DOS and its predecessor, 86DOS, resembled Digital Research's CP/MA, the dominant disk operating system for 8-bit Intel 8080 and Zilog Z80-based microcomputers. DOS instead ran on Intel 8086 16-bit processors. Starting with PC DOS 2.0, the operating system incorporated various features inspired from Xenix, Microsoft's variant of Unix. When IBM introduced the IBM PC, built with the Intel 8088 microprocessor, they needed an operating system. Seeking an 8088-compatible build of CP/M, IBM initially approached Microsoft CEO Bill Gates. IBM was sent to Digital Research, and a meeting was set up. However, the initial negotiations for the use of CP/M broke down. Digital Research wished to sell CP/M on a royalty basis, while IBM sought a single license, and to change the name to PC-DOS. Digital Research founder Gary Kildall refused, and IBM withdrew. IBM again approached Bill Gates. Gates in turn approached Seattle Computer Products. There, programmer Tim Patterson had developed a variant of CP/M80, intended as an internal product for testing SCP's new 16-bit Intel 8086 CPU card for the S100 bus. The system was initially named QDOS, before being made commercially available as 86DOS. Microsoft purchased 86DOS, allegedly for $50,000. This became Microsoft Disk Operating System, MS-DOS, introduced in 1981. Microsoft also licensed their system to multiple computer companies, who supplied MS-DOS for their own hardware, sometimes under their own names. Microsoft later required the use of the MS-DOS name, with the exception of the IBM variant. IBM continued to develop their version, PC-DOS, for the IBM PC. Digital Research became aware that an operating system similar to CP/M was being sold by IBM, and threatened legal action. IBM responded by offering an agreement: they would give PC consumers a choice of PC-DOS or CP/M86, Kildall's 8086 version. Side by side, CP/M cost almost $200 more than PC-DOS, and sales were low. CP/M faded, with MS-DOS and PC-DOS becoming the marketed operating system for PCs and PC compatibles. Microsoft originally only sold MS-DOS to original equipment manufacturers. One major reason for this was that not all early PCs were 100% IBM PC compatible. DOS was structured such that there was a separation between the system-specific device driver code and the DOS kernel. Microsoft provided an OEM adaptation kit which allowed OEMs to customize the device driver code to their particular system. By the early 1990s, most PCs adhered to IBM PC standards, so Microsoft began selling MS-DOS in retail with MS-DOS 5.0. In the mid-1980s, Microsoft developed a multitasking version of DOS. This version of DOS is generally referred to as European MS-DOS 4, because it was developed for ICL and licensed to several European companies. It was never released to the general public or any other OEMs. This version of DOS supports preemptive multitasking, shared memory, device helper services and new executable format executables. None of these features were used in later versions of DOS, but they were used to form the basis of the OS/DO 1.0 kernel. This version of DOS is distinct from the widely released PCA-DOS 4.0, which was developed by IBM and based upon DOS 3.3. Digital Research attempted to regain the market lost from CP/M86. Initially with concurrent DOS, FlexOS and DOS+, later with multi-user DOS and DRA-DOS. Digital Research was bought by Novell, and DRA-DOS became Novell DOS 7. Later, it was part of Caldera, Linneo, and Device Logix. At first Microsoft expected that DOS would be an interim solution before Unix became the company's operating system of the future. Gordon Litwin wrote in 1995 that DOS was, when we first wrote it, a one-time throwaway product intended to keep IBM happy so that they'd buy our languages. After AT&T began selling Unix, the company and IBM began developing OS/DO. Microsoft and IBM later had a series of disagreements over two successor operating systems to DOS, OS/DO and Microsoft's Windows. They split development of their DOS systems as a result. The last retail version of MS-DOS was MS-DOS 6.22, after this MS-DOS became part of the Windows 95 ME bundle. The last retail version of PC-DOS was PC-DOS 2000, though IBM did later develop PC-DOS 7.10 for OEMs and internal use. The FreeDOS project began June 26, 1994, when Microsoft announced it would no longer sell or support MS-DOS. Jim Hall then posted a manifesto proposing the development of an open-source replacement. Within a few weeks, other programmers including Pat Villani and Tim Norman joined the project. A kernel, the command.com command line interpreter and core utilities were created by pooling code they had written or found available. There were several official pre-release distributions of FreeDOS before the FreeDOS 1.0 distribution was released on September 3, 2006. Made available under the GNU General Public License, FreeDOS does not require license fees or royalties. Decline. Early versions of Microsoft Windows ran on top of a separate version of DOS. By the early 1990s, Windows saw heavy use on new DOS systems. In 1995, Windows 95 was bundled as a standalone operating system that did not require a separate DOS license. With Windows 95, the MS-DOS kernel remained, but with Windows as the system's graphical shell. With Windows 95 and 98, but not ME, the MS-DOS component could be run without starting Windows. With DOS no longer required to use Windows, the majority of PC users stopped using it directly. Continued use. Available DOS systems in 2012 are FreeDOS, Dr. DOS, ROM-DOS, PTS-DOS, RX-DOS and Real/32. Some computer manufacturers, including Dell and HP, sell computers with FreeDOS as the OEM operating system. Embedded systems, DOS's structure of accessing hardware directly makes it ideal for use in embedded devices. The final versions of Drive DOS are still aimed at this market. ROM-DOS was used as the embedded system on the Canon PowerShot Pro 70. Emulation. Under Linux, it is also possible to run copies of DOS and many of its clones under DOSMU, a Linux-native virtual machine for running DOS programs at near-native speed. There are a number of other emulators for running DOS under various versions of Unix, even on non-x86 platforms, such as DOSBox. DOS emulators are gaining popularity among Windows XP and Windows Vista users, due to these systems being very incompatible with pure DOS. They can be used to run games or other DOS software. One of the best known is DOSBox, designed for legacy gaming on modern operating systems. It is possible to run DOS applications in a copy of a DOS operating system on a PC emulator, allowing better compatibility than DOS emulators where the emulation of the DOS operating environment is imperfect. Design. All MSDOS type operating systems run on machines with the Intel x86 or compatible CPUs, mainly the IBM PC and compatibles. Machine-dependent versions of MS-DOS were produced for many non-IBM compatible x86-based machines, with variations from relabeling of the Microsoft distribution under the manufacturer's name, to versions specifically designed to work with non-IBM PC compatible hardware. For as long as application programs used DOS APIs instead of direct hardware access, they could thereby also run on non-IBM PC compatible machines. In 1985, Digital Research also had a version of concurrent DOS 68K for use on Motorola 68000 CPUs, and the original FreeDOS kernel DOS-C derived from DOS-NT, also for Motorola CPUs, in the early 1990s. While these systems resembled the DOS architecture, applications were not binary compatible due to the incompatible instruction sets of these non-x86 CPUs. However, applications written in high-level languages could be ported easily. DOS is a single-user, single-tasking operating system with basic kernel functions that are non-reentrant. Only one program at a time can use them, and DOS itself has no functionality to allow more than one program to execute at a time. The DOS kernel provides various functions for programs, like character I/O, file management, memory management, program loading and termination. DOS by default provides a primitive ability for shell scripting, via batch files. These are text files that can be created in any text editor. They are executed in the same fashion as compiled programs, and run each line of the batch file as a command. Batch files can also make use of several internal commands, such as GOTO and conditional statements. GOSUB and simple arithmetic is supported with the DOS-command.com as well as some with third-party shells like FreeDOS. However, no real form of programming is usually enabled. The operating system offers an application programming interface that allows development of character-based applications, but not for accessing most of the hardware, such as graphics cards, printers, or mice. This required programmers to access the hardware directly, usually resulting in each application having its own set of device drivers for each hardware peripheral. Hardware manufacturers would release specifications to ensure device drivers for popular applications were available. Boot sequence: the bootstrap loader on PC-compatible computers is located at track 0, the first sector on a disk. The ROM BIOS will load this sector into memory at address 0000H, 7C00H, and typically check for a signature 55H or at offset +1 Fa. If the sector is not considered to be valid, the ROM BIOS will try the next physical disk in the row, otherwise it will jump to the load address with certain registers set up. If the loaded boot sector happens to be a master boot record, as found on partitioned media, it will relocate itself to 0000H, 0600H in memory, otherwise this step is skipped. The MBR code will scan the partition table, which is located within this sector, for an active partition, and, if found, load the first sector of the corresponding partition, which holds the volume boot record of that volume, into memory at 0000H, 7C00H in the similar fashion as it had been loaded by the ROM BIOS itself. The MBR will then pass execution to the loaded portion with certain registers set up. The sector content loaded at 0000H, 7C00H constitutes a VBR now. VBRs are operating system specific and cannot be exchanged between different DOS versions in general, as the exact behavior differs between different DOS versions. In very old versions of DOS such as DOS 1X, the VBR would load the whole IOS's IBM.bio.com file into memory at 0000H, 0600H. For this to work, these sectors had to be stored in consecutive order on disk by SYS. In later issues, it would locate and store the contents of the first two entries in the root directory at 0000H, 0500H, and if they happen to reflect the correct boot files as recorded in the VBR would load the first three consecutive sectors of the IOS's IBM.bio.com file into memory at 0070H, 0000H. The VBR also has to take care to preserve the contents of the disk parameter table. Finally, it passes control to the loaded portion by jumping to its entry point with certain registers set up. In modern DOS versions, where the VBA has loaded only the first 3 sectors of the IOS's IBM-BIO.com file into memory, the loaded portion contains another bootloader, which will then load the remainder of itself into memory, using the root directory information stored at 0000H, 0500H. For most versions, the file contents still need to be stored in consecutive order on disk. In older versions of DOS, which were still loaded as a whole, this step is skipped. The DOS system initialization code will initial its built-in device drivers and then load the DOS kernel, located in MSDOS's on MS-DOS systems, into memory as well. In Windows 9X, the DOS system initialization code and built-in device drivers and the DOS kernel are combined into a single IOS's file, while MS-DOS's is used as a text configuration file. The configsys file is then read to parse configuration parameters. The shell variable specifies the location of the shell, which defaults to command.com. The shell is loaded and executed. The startup batch file autoexec.bat is then run by the shell. The DOS system files loaded by the boot sector must be contiguous and be the first 2 directory entries. As such, removing and adding this file is likely to render the media unbootable. It is, however, possible to replace the shell at will, a method that can be used to start the execution of dedicated applications faster. This limitation does not apply to any version of DOS, where the system files can be located anywhere in the root directory and do not need to be contiguous. Therefore, system files can be simply copied to a disk provided that the boot sector is DOS compatible already. In PC-DOS and DOS 5.0 and above, the DOS system files are named IBM-BIO.com instead of IOS's and IBM-DOS.com instead of MS-DOS's. Older versions of DOS used DRBIOS's and DRBDOS's instead. File system: DOS uses a file system which supports 8.3 file names. 8 characters for the file name and 3 characters for the extension. Starting with DOS, 2 hierarchical directories are supported. Each directory name is also 8.3 format, but the maximum directory path length is 64 characters due to the internal current directory structure tables that DOS maintains. Including the drive name, the maximum length of a fully qualified file name that DOS supports is 80 characters using the format drive, /path /file name ext followed by a null byte. DOS uses the file allocation table file system. This was originally FAT12, which supported up to 4078 clusters per drive. DOS 3.0 added support for FAT16, which used 16-bit allocation entries and supported up to 65,518 clusters per drive. DOS 3.31 added support for FAT16B, which removed the 32 MB drive limit and could support up to 2 GB. Finally, MS-DOS 7.1 added support for FAT32, which used 32-bit allocation entries and could support hard drives up to 137 GB and beyond. Starting with DOS 3.1, file redirector support was added to DOS. This was initially used to support networking but was later used to support CD-ROM drives with MSCDEX. IBM PC DOS 4.0 also had preliminary installable file system support, but this was unused and removed in DOS 5.0. Drive naming scheme. In DOS, drives are referred to by identifying letters. Standard practice is to reserve A and B for floppy drives. On systems with only one floppy drive, DOS assigns both letters to the drive, prompting the user to swap disks as programs alternate access between them. This facilitates copying from floppy to floppy or having a program run from one floppy while accessing its data on another. Hard drives were originally assigned the letters C and D. DOS could only support one active partition per drive. As support for more hard drives became available, this developed into first assigning a drive letter to each drive's active primary partition, then making a second pass over the drives to allocate letters to logical drives in the extended partition, then a third pass to give any other non-active primary partitions their names. Lastly, DOS allocates letters for optical disk drives, RAM disks, and other hardware. Letter assignments usually occur in the order the drivers are loaded, but the drivers can instruct DOS to assign a different letter. Drivers for network drives, for example, typically assign letters nearer the end of the alphabet. Because DOS applications use these drive letters directly, they can be disrupted by adding new hardware that needs a drive letter. An example is the addition of a new hard drive having a primary partition where a pre-existing hard drive contains logical drives in extended partitions. The new drive will be assigned a letter that was previously assigned to one of the extended partition logical drives. Moreover, even adding a new hard drive having only logical drives in an extended partition would still disrupt the letters of RAM disks and optical drives. This problem persisted through Microsoft's DOS-based 9X versions of Windows until they were replaced by versions based on the NT line, which preserves the letters of existing drives until the user changes them. Under DOS, this problem can be worked around by defining a SUBST drive and installing the DOS program into this logical drive. The assignment of this drive would then be changed in a batch job whenever the application starts. Under some versions of concurrent DOS, as well as under multi-user DOS, System Manager and Real/32, the reserved drive letter L will automatically be assigned to the corresponding load drive whenever an application starts. Reserved device names. There are reserved device names in DOS that cannot be used as file names regardless of extension as they are occupied by built-in character devices. These restrictions also affect several Windows versions, in some cases causing crashes and security vulnerabilities. The reserved names are CON, O, PRN and LST, which were introduced with 86DOS 0.74. 86DOS 1.10 and PCA-DOS 1.0 added NUL. Except for LST, they continued to be supported in all versions of MS-DOS, PC-DOS and Drive-DOS ever since. LST was also available in some OEM versions of MS-DOS 1.25, whereas other OEM versions of MS-DOS 1.25 already used LPT1 and COM1 instead, as introduced with PC-DOS. COM2, LPT2, LPT3 and the clock device were introduced with DOS 2.0, and COM3 and COM4 were added with DOS 3.3. Only the multitasking European MS-DOS 4 supported KEYBD$ and screen $. Dr. DOS 5.0 and higher and multi-user DOS support and $idle device for dynamic idle detection to saving power and improve multitasking. LPT4 is an optional built-in driver for a fourth-line printer supported in some versions of Drive-DOS since 7.02. Config$ constitutes the real mode PNP manager in MS-DOS 7.0-8.0. O typically defaults to COM1, and PRN to LPT1, but these defaults can be changed in some versions of DOS to point to other serial or parallel devices. File names ended with a colon such as NUL, conventionally indicate device names, but the colon is not actually a part of the name of the built-in device drivers. Colons are not necessary to be typed in some cases, for example. It is still possible to create files or directories using these reserved device names, such as through direct editing of directory data structures in disk sectors. Such naming, such as starting a file name with a space, has sometimes been used by viruses or hacking programs to obscure files from users who do not know how to access these locations. Memory management. DOS was originally designed for the Intel 8086/8088 processor and therefore could only directly access a maximum of 1 MB of RAM. Due to PC architecture, only a maximum of 640 KB is available as the upper 384 KB is reserved. Specifications were developed to allow access to additional memory. The first was the expanded memory specification, which originally allowed memory on an add-on card to be accessed via a 64 KB page frame in the reserved upper memory area. 80,386 and later systems could use a virtual 8086 mode memory manager like M386 to create expanded memory from extended memory without the need of an add-on card. The second specification was the extended memory specification for 80,286 and later systems. This provided a way to copy data to and from extended memory, access to the 65,520 byte high memory area directly above the first megabyte of memory and the upper memory block area. Generally XMS support was provided by HMMSys or a v86 mode memory manager like QEMM or 386 Max, which also supported EMS. Starting with DOS 5, DOS could directly take advantage of the HMA by loading its kernel code and disk buffers there via the DOS equals high statement in configs. DOS 5 Plus also allowed the use of available UMBs via the DOS equals UMB statement in configs, DOS under OS/2 and Windows. The DOS emulation in OS/2 and Windows runs in much the same way as native applications do. They can access all of the drives and services, and can even use the host's clipboard services. Because the drivers for file systems and such forth reside in the host system, the DOS emulation needs only provide a DOS API translation layer which converts DOS calls to OS/2 or Windows system calls. The translation layer generally also converts BIOS calls and virtualizes common I/O port accesses which many DOS programs commonly use. In Windows 3.1 and 9X, the DOS virtual machine is provided by WinOldApp. WinOldAP creates a virtual machine based on the program's PIF file, and the system state when Windows was loaded. The DOS graphics mode, both character and graphic, can be captured and run in the window. DOS applications can use the Windows clipboard by accessing extra published calls in WinOldAP, and one can paste text through the WinOldAP graphics. The emulated DOS in OS/2 and Windows NT is based upon DOS 5. Although there is a default configuration, one can use alternate files on a session-by-session basis. It is possible to load drivers in these files to access the host system, although these are typically third-party. Under OS/2 2X and later, the DOS emulation is provided by DOS-KRNL. This is a file that represents the combined IBM-BIO.com and IBM-DOS.com. The system calls are passed through to the OS/2 windowing services. DOS programs run in their own environment. The bulk of the DOS utilities are provided by bound DOS/OS2 applications in the /OS2 directory. OS/2 can run Windows 3.1 applications by using a modified copy of Windows. The modifications allow Windows 3.1 programs to run seamlessly on the OS/2 desktop, or one can start a Windows/2 desktop, similar to starting Windows from DOS. OS/2 allows for DOS from Drive A. This is a real DOS, like MS-DOS 6.22 or PCA-DOS 5.00. One makes a bootable floppy disk of the DOS, add a number of drivers from OS/2, and then creates a special image. The DOS booted this way has full access to the system, but provides its own drivers for hardware. One can use such a disk to access CD-ROM drives for which there is no OS/2 driver. In Windows NT, the DOS emulation is provided by way of a virtual DOS machine. The DOS files reside in NTIOSes and NTBIOSes as usual, but run in the virtual machine provided by NTVDM. The character input is passed to the console session that launched a DOS program. This allows one to use CLI features such as pipes and redirection between DOS and Windows NT. The OS/2 emulation in NT in 2000 is similar, but no virtual machine is loaded. It is handled by OS/2 and OS/2 EXE. 64-bit versions of Windows do not support NTVDM and cannot run 16-bit DOS applications directly. User interface. DOS systems utilize a command line interface. Programs are started by entering their file name at the command prompt. DOS systems include several programs as system utilities. and provides additional commands that don't correspond to programs. In an attempt to provide a more user-friendly environment, numerous software manufacturers wrote file management programs that provided users with menu and/or icon-based interfaces. Microsoft Windows is a notable example, eventually resulting in Microsoft Windows 9X becoming a self-contained program loader, and replacing DOS as the most used PC-compatible program loader. Text user interface programs included Norton Commander, DOS Navigator, Volkov Commander, Quarterdesk DiskView, and Sidekick. Graphical user interface programs included Digital Research's Graphical Environment Manager and GEOS. Eventually, the manufacturers of major DOS systems began to include their own environment managers. MS-DOS IBM DOS-4 included DOS Shell. Dr. DOS 5.0, released the next year, included ViewMax, based upon GEM. Terminate and stay resident. DOS is not a multitasking operating system. DOS did however provide a terminate and stay resident function which allowed programs to remain resident in memory. These programs could hook the system timer and/or keyboard interrupts to allow themselves to run tasks in the background or to be invoked at any time, preempting the current running program, effectively implementing a simple form of multitasking on a program-specific basis. The print command did this to implement background print spooling. Ball and Sidekick, a pop-up personal information manager, also used this technique. Terminate and stay resident programs were also used to provide additional features not available by default. Programs like CED and DOSKey provided command line editing facilities beyond what was available in Command.com. Programs like the Microsoft CD-ROM extensions provided access to files on CD-ROM disks. Some TSRs could even perform a rudimentary form of task switching. For example, the shareware program Back and Forth had a hotkey to save the state of the currently running program to disk, load another program, and switch to it, hence it was possible to switch back and forth between programs, albeit slowly due to the disk access required. Back and Forth could not enable background processing, however. That needed disk view. Software. DOS was the dominant PC-compatible platform and many notable programs were written for it. These included, FreeDOS, a much-improved replacement shell. Arachne, a 16-bit graphical DOS web browser. Basic language interpreters. BASIC and GW Basic replicate the BASIC interpreter environment commonly found on 8-bit computers. DBase, one of the earliest database programs. DJGPP, the 32-bit DPMI DOS port of GCC. Harvard Graphics, one of the earliest presentation graphics design programs. Lotus 1-2-3, a protected mode spreadsheet program that saw heavy use in corporate markets and has been credited with the success of the IBM PC. Microsoft Macro Assembler, Microsoft C and CodeView, all part of Microsoft development software. Norton Commander and Xtree, file management utilities. Norton Utilities, a collection of disk and system utilities. PC Tools, a collection of disk and system utilities. PKZIP, the compression utility that quickly became the standard in file compression. Procom, CModem and Telix, modem communication programs. QEMM and 386 Max, DOS memory management utilities. Sidekick, a pop-up personal information manager. Turbo Pascal, Turbo Basic, Turbo C and Turbo Assembler, all part of Borland's integrated development environment. Vern Bjork's popular list utility, which displays the content of files in ASCII or hex. WordPerfect, a word processor that is currently produced for the Windows platform. WordStar, an early word processor which used unique control key sequences that were replicated by many other editors. See also, Command.com, the command line interpreter for DOS and MIS Windows 9X, MS-DOS API, VGA-compatible text mode, the base of DOS, a Euro-unregistered trademark STUI on IBM PC compatibles, timeline of DOS operating systems, references. Notes. External links. Timeline of DOS and Windows versions at the Wayback Machine, DOS, where hardware is the only limit at the Wayback Machine, BAT files, the DOS Batch File Programming Handbook.